Then we are into introduction of finite element method. So we are about to complete this chapter, and then we'll start about model idealization, then finite element modeling, then loads and boundary conditions and analysis techniques. So this is the coursework which we planned for this semester. I hope you might have received this communication. Like I'll be sending this document to your coursework and it will be shared across me. I hope I am audible and you can see the slides as well. If you have any issues, just I think last week we were discussing about shape functions. Just I want to continue further on that. So before proceeding further on shape functions, again just I want to analysis. One is the global coordinate system, which is an indicated in the global. So then we have to use local coordinate systems. So this is our global coordinate system. So suppose for example for this element, this is the global origin, global census, and this one is a local coordinate. So sometimes we need to have this global and local coordinate systems for easy post processing and easy modeling. And so these are the things we generally use for stress analysis. But coming to shape functions uses another coordinate system, natural coordinate system. So just to understand what is this natural coordinate system. So this natural coordinate system is a dimensionless number which we have minus 1 to 1. It ranges from minus 1 to 1. And it is very easy. This coordinate system is very easy computation of integrals and formulation. So this is exclusively used in finite element formulations. So coming to global versus local, what exactly is the relation between global versus local? So this is our local coordinates. We started in the node I, and global is somewhere far away from local. So the relation between these two things is x equation xi plus x. Xi is nothing but the distance between global and local. That is called as xi. Or what we can say, the location of coordinates I node coordinate. So that is given by xi. So this is the relation between given. Then when you try to put it in a shape function, you additional so we will try to this is our shape function equation in terms of displacement. So we will try to substitute shape functions here in terms of natural coordinates. Shape functions. So let us understand more on isoparametric shape functions. So when shape functions are derived using natural coordinate system, usually we will call it as a isoparametric shape function. So they are so why we need to use these shape functions regarding isoparametric shape functions? So whenever you try to use equations expressed in local coordinates system, it is very difficult in terms of computation. Okay? So not easy to usually what this shape functions in terms of natural coordinate system derived using natural coordinate system always helpful in solving quickly and for all the element combination. So one of the important thing is like even though they are complex, but they are very easy for computation problem. So one of the advantage of isoparametric formulation is whatever the element shape. Okay?
Class login है?
हाँ सर ठंडा था
Class 1 login है?
फाइन नंबर सर
Not by element orientation local coordinates. So one of the important aspects is this element numbers are formatted
Jntuk కాకినాడ Jntuk విజయనగరం
by element geometry.
Jntuk
By
के
element
डबल
orientation.
3 सर Jntuk के
Actual
6
coordinate is attached to the bar and remains
साल दो सर
parallel on
5 सर
angle and how the bar is oriented to space. So here, see, this is the bar. Okay. This coordinate, zeta coordinate, angle coordinate will be along the bar, not in any other direction. So this natural coordinate system, important aspect is to align according to the and every day. So this is the overall shape function for this specific.
దాన్ని మళ్ళీ ఏమన్నారంటే మార్క్స్ వేసాం
So coming to isoparametric shape function, when you try to whatever we discussed, which is the higher order shape function can be done by adding additional nodes. So one node here inside node, then this will be higher order element.
మీ దగ్గర ఉంటారు
Actually, by adding one node inside nodes,
అంతే
the convergence of the current element
ఏ సార్ ఏసీ సార్
will be positive.
6 కాలేజ్
Results convergence. When you try to solve when you try to apply loads in the construct and try to solve model, it will give one value. Okay. So what is the accuracy of that model? We need to check the accuracy of results for a particular time. So same thing if you use that is for then try to without value. The accuracy will be increased. That is we will discuss in detail under convergence process. But convergence can be easily achieved by a mixed. So when you try to put a mixed node for this bar element, the shape they will be getting 3 shape functions because we have 3 nodes here, Ni, J and K, and they are related to like this. These are the shape functions for bar element mixed. Similarly, shape functions for 2D are given as like this. So 2D is nothing but it's an area element. So there are 4 nodes will be there, M1, M2, M3, and okay. When you try to map onto natural coordinate system, looks like the surface is there, whereas it is not actual shape is not surface there. But when you try to map onto natural coordinate system, as we discussed, it varies from -1 to 1. So it looks like perfect square. Then when you try to derive this shape function, these are the shape functions. M1, M2, M3, and similarly, when you try to put a higher order 2D element, that means when they have mid-side nodes, 1, 2, 3, 4 are corner nodes, 5, 6, 7, 8 are mid-side nodes. So when you try to put these nodes, you will be having 8 shape functions like this, and other so I'll elaborate in next session. So these are the corner node shape functions. Similarly, for isoparametric 3D shape functions, this is a volume element, and we will be having 8 corners. Okay. So 8 corner nodes will have 8 shape functions. Each corner node will have 1 shape function. So total 8 nodes, 8 shape functions.
free
So that completes our is there, finite element procedures by Bartley. So these are the 5 books which I refer for preparing this material. But we also try to refer some of these books which are good. Try to understand concepts, finite element concepts, which are required for allowing performance stress analysis. So coming to other topic, just I want to give more briefing on what are the different types of analysis. Static analysis, as name indicates, there is no dynamic effects in the system. Static analysis can be linear as well as non-linear analysis. So we'll discuss what is the difference between linear analysis and non-linear analysis. Non-linear will be existent in the materials. So when you see the stress strain curve, okay, stress strain curve exists linear up to behind that there will be non-linearity existing. So your loading is behind yield point, then we may need to consider linearity of the materials, which is like geometry non-linearity is associated with that. When load is applied, there will be a drastic change in the shape of the geometry. So that also we need to recall. It all depends upon geometry of the model. And then third type of non-linearity will be on contacts. There is some contact. Then we need to see the contact elements that will have another contact. So there static analysis can be either linear or non-linear. So when you say I want to understand static analysis, linear analysis, non-linear analysis. So linear and non-linear will be same for static loads. Static loads we have different types of loads. For some of the things are gravity and rotational loads. Similarly, we have buoyant loads, pressure loads, mechanical loads. Okay, so things are. Is that every equation F equals to KU for the static analysis, where F is a global model process, K is the global stiffness matrix, and V is the model matrix of the displacement. So coming to transient analysis, what is the transient analysis? So when a structure system is subjected to load, and that load is varying with respect to time, that is called as a transient analysis. So for example, this is the equation of motion, okay, subjected to force, and force is a function of time. As time changes, force also will change. So this type of loading, when a component is subjected to this type of loading, then we need to do transient analysis. So transient excitation is highly time dependent force exerted on the solid structure. Some of the examples will be earthquake, impact and shock. They will be varying drastically with respect to time. The loading will be very drastic. Structural response will be there. Of course, this is the mass matrix. U is the acceleration vector, and C is the damping matrix. U is the velocity vector. K is the stiffness matrix. So coming to transient analysis, there are two ways we can solve the transient analysis. One is implicit way, other is explicit way. So generally implicit is very efficient for very slow events, and explicit method is very fast and very efficient for very fast events, such as and extrusion.
చేస్తాను
Let us discuss more on
చేస్తాను
start discussing.
డైరెక్ట్గా చేస్తాను
So, as you know, implicit method generally stiffness matrix equation will be carried. The stiffness matrix involves
లేనప్పుడు అలా చేసిందా
very,
సార్ మీరు?
very complicated geometries. Is computationally tedious. Take a lot of time while solving the inverse matrix. So that is why implicit method take a lot of time. So one of the important benefit for the this method is it is unconditionally stable. That means
ఏది ఇచ్చిందంటే ఎవరైనా పాత ప్రూఫ్ కూడా పట్టుకుని
when you try to solve using implicit method, it will be this method is unconditionally stable. There is no upper limit for the time step. Change the time step. So
తరగకుండా తీసుకురావాలి కవర్ పట్టుకోండి
suppose
వచ్చింది స్కాన్
stable. So it is independent of time step. Are you able to see my desktop? I think somebody mentioned about they are unable to see the desktop. Any issues with my desktop?
అదే పెట్టలేదా మరి అదే స్టూడెంట్స్ లేరా వాళ్ళకి అదే టైంలో ఇంకో క్లాస్ జరుగుతుంది అందుకని చెప్పి సార్ ప్రతిదీ రికార్డ్ చేసి పెట్టుకో ప్రసాద్ ఏసీఐఏ ఓన్లీ మిగతా స్టూడెంట్స్ వస్తున్నారు అయిపోయిందా సెషన్ అవుతుంది సార్ లక్ష్మణ్ గారు సార్ చెప్పండి సార్
Desktop sharing is problem.
రావట్లేదు సార్ నాకు డెస్క్టాప్ షేరింగ్ ఇప్పుడే చూసానండి నాకు కూడా రావట్లేదు డెస్క్టాప్ షేరింగ్ ఒక్క నిమిషం సార్ చూస్తున్నాను వచ్చిందండి వచ్చింది ఓకే సార్ వచ్చింది సార్
Yeah, just check it out now. I share it again. So nonlinear system. So which can be used in static analysis as well. And we can use the steady loads such as gravity and rotational load, in addition to regular pressure loads. These two equations here, A is considered constant, and transient analysis we need to do transient analysis when the system is subjected to the load, which is a function of time. So excitation from excitation is highly time dependent. So when the force is applied and it is varying function of time. So sometimes what there is cycling load. So there will be like load variation happening in the component or the function of time. So here I am in the mass matrix. Here U double dot is the acceleration vector, C is the damping matrix, U is the velocity velocity vector, K is the displacement. Okay, the force which is very generally we use this equation to solve transient analysis. There are here like transient analysis can be solved two ways. One is the implicit method, other is the explicit method. Implicit method is more efficient for slow events, and explicit method is more efficient for the fast events. This is more detailed. So we are discussing on this implicit method. So in implicit method, the stimulus matrix is inverted at every time step. Turns to our case. So generally when you try to solve transient analysis using implicit method, so it will be divided into small steps. Right is on this substep. So what will happen with each substep? This stimulus matrix will be each substep. Most of stimulus matrix will take a lot of computational time. So there is another disadvantage in this method, and this method is unconditionally stable. When you change the time step, not only depending on the time step, then even then it will be stable solution. So in this method, So in explicit method, stiffness point, stiffness matrix will be updated or calculated based on the geometry changes and integral. So here in the explicit method, increment should be it should not be changed. It should not be increased. And most importantly, more than forcing equilibrium between
ఆయన కూర్చున్నాడేమో అనుకున్నాను నిన్న అన్నారు కదా ఫోన్ ఇచ్చిరక్కన
regarding to time step, we cannot change the time step to particular critical value for a particular problem. The critical time step value will be calculated based on the element size. So our time step should not cross the critical time step. If it crosses
సిమెంట్
the limit time step,
తీసాడు ఒక
critical time step,
వీసా నాకు వడకం తీసుకో
results accuracy will be
తీసుకో ఎక్కువ తీసుకో
compromised.
వందలు తీసుకో
So the programs understand and can also be divided for the explicit methods.
అదే మళ్ళీ పాడవుతాడా సరిపోతుంది
And this method can be exclusively used for automobile
సింగిల్గా వాడు
road impact
నెంబర్ అందరికి ఇచ్చుకోవాలి ఆ నెంబర్ అందరికి ఇచ్చుకునే నెంబర్
and road analysis and theory. So coming to formulation, this is our equation of motion. When you try to use this type of equations, these two factors will be sent to that side.
సింగిల్ అయితే
And here we are inverting only mass matrix. So that is the reason it will be very fast. Mass matrix is inversely is very less expensive compared to stress matrix. So inverting mass matrix is generally much less computationally expensive. Subsequently, velocities and displacements are evaluated. So here angular accelerations are calculated. Subsequently, velocities and displacements are evaluated. This method is conditionally stable. Remember the statement for implicit method, that is unconditionally stable, but this is conditionally stable. That means if time step becomes too large than incremental time step,
చూపించడం
then computational solution become unstable. So this is a very important step, important point. So this method is conditionally stable. That means the time step should not be larger than the critical time step. Otherwise, it will the model will become unstable.
ప్రతి సిమ్మితే
So the time steps are 1000 to
ఎప్పటి నుంచో వాడిన అందరూ అలాగే అంటారా
times smaller than the implicit. Means explicit method time steps are very small compared to
పేపర్
implicit methods.
ఎప్పటి నుంచో అంటే ఎంతకాలం నుంచి వాడుతుంది దీన్ని
So these are the some of the
ఎవరు అనరా నీది సెవెలు రీచ్ అవ్వదని ఇక్కడే అవ్వట్లేదు సార్ ఇంట్లో బాగానే ఉంటుంది తప్పిసేవా దీన్ని సార్ పూర్వంతో తెలిపేవా నడపడం అంటే ఎలాగంటే ఫోన్తో పాటు పడుతుంది అదే తగ్గుతుంది సార్ ఎందుకంటే ఇలాగా టచ్ ఫోన్ ఉంది సార్ టచ్ ఫోన్లో వేసి ఆడుతుండగా ఏం జరిగిందంటే ఇలా చేయి కడుక్కుంటాం కదా సార్ పై జోబులో పెట్టి కడుక్కుంటుంటే హమాదంగా వెళ్ళి బకెట్లో పెట్టుకుంటాం వెంటనే తీసి క్లీన్ చేసేసి శుభ్రం చేసేసాను చేసేస్తే అది టచ్ పోయింది తగ్గించాను చేస్తానంటే చేయాలి అయిపోయింది సర్వీస్ అయిపోయింది అర్జెంట్గా సిమ్ అయినా మార్పించుకో లేకపోతే కొత్త నెంబర్ అని తీసుకో టాటా డోకోమోలో కొత్త సిమ్ తీసుకో కొత్త సిమ్ తీసుకొని టాటా డోకోమో కదా సార్ కేబుల్ తీసుకున్నాం డోకోమోలో కొత్త సిమ్ తీసుకో
So when you get a stress analysis problem, okay, then one of the important steps we need to do is model idealization. Okay. So model idealization is, suppose if we have any complicated geometry, we want to do any analysis on a complicated geometry, we need to understand what is our area of interest, what type of model we need to construct,
ఉంది సార్ ఉంది సార్. నేను చెప్పానా సార్? ఓకే సార్ వస్తున్నాను. సార్ లంచ్కి కానీ వెళ్తారు 12:30కి వెళ్తారా?
మామూలుగా 12:30. ఏదన్నా మిస్సింగ్ అయితే 1 అవుతుంది. ఇంకా మిస్సింగ్ అయిందని 2:30 దాకా ఉండిపోయి మధ్యాహ్నం దానికి వస్తుంది అంటుంది. 3 దాకా
designing movements generally we need to give to the design team. So that is our one of the important stress analysis. So once it is have good margins, then analysis will be good. So sometimes what will happen, there is for this job that does not have good margins, we may complete our work here because that work will be taken care of.
అది పని చేస్తా సార్, కానీ ఒకసారి అట్లా లేదని వచ్చేస్తుంది. ఎందుకు సార్ ఇప్పుడు కూడా వచ్చింది మనకి.
So today we'll have a brief introduction about model idealization. Then, we'll stop. So generally, this model idealization is need to be carried out because generally our structures are very very complex. So, for example, take this example. This is the
అయితే సార్ దీన్ని ఐడియాకి పోర్టబిలిటీ పెట్టేసుకుంటాం.
it is carrying some
అది
content.
మామూలుగా ఎట్టాల్సిన తీసేసుకొని ఎందుకంటే సార్ ఆల్రెడీ పొద్దున్న ఎప్పుడో పెట్టాను నేనే పెట్టాను.
What is the
దీన్ని కరెక్ట్గా ఎప్పుడో మెసేజ్ పెట్టాను. చిన్నసార్లు వచ్చి ఓపెన్ చేసి క్లాస్ స్టార్ట్ అయ్యి అన్ని రికార్డింగ్ చేసేటప్పుడు 10కి వచ్చింది మెసేజ్.
workloads here distributed over time. We can do the analysis. This is one way of model idealization. So reducing the complexity of the problem without compromising results. Analysis techniques. So this is what model idealization.
వెళ్ళి పెట్టాల్సిన
So model idealization depends upon various factors. Some other factors I mentioned.
చూసుకుని నంబర్
Right. So what level we can compromise on and types of analysis, what type of analysis. Okay. So some of the idealization techniques can support the types of analysis and the types of what type of. So some of the things which these things idealization techniques. So suppose if I need to solve this latest, is it worth to solve take model all these plates solve, or can we take only single plate and solve? So what type of
మిగతా వాళ్ళు అవైలబుల్ అవుతారు.
model idealization
ఇంకో కాలేజ్ ఉందా కూడా
solve
ఉండాలా?
Single is condition. No need to carry complete system. Single we can solve.
కంప్యూటర్ వాళ్ళు అయితే అసలు పట్టించుకోవట్లేదు క్లాస్లో వస్తున్నారు.
క్లాస్ ఇంట్లో వస్తుంది కదా.
అదేంటి మేడం అంటే వాళ్ళు లేదు కదమ్మా మేడం అని అడిగితే దీనికి ఏంటి సపోర్టింగ్ అవుతుంది జాబ్స్కి
ప్లేస్మెంట్
ప్లేస్మెంట్స్ కోసం ప్రిపేర్ అవుతున్నారు.
మేడమే ఏమంటలేదా?
మేడం మేడం ప్లేస్మెంట్స్ కోసం ప్రిపేర్ అవుతున్నారు.
సారీ చెప్పారు వాళ్ళు సారీ చెప్పాలి మరి. ఇట్లా జరుగుతుందమ్మా క్లాస్లోనూ మళ్ళీ ఎవరు ఇంట్లో సరిగ్గాను
మేడం చాలా
అప్పుడు చెప్పాలి. అప్పుడు సార్ ఇదండి పరిస్థితి మేడం మనకి ప్లేస్మెంట్ ప్రిపేర్ అవుతారు వాళ్ళు చెప్పేసి ఉంటారు. ఉన్నది లేనిది చెప్పట్లేదు.
అడిగాను సార్ అడిగాను ఇవ్వాలి మేడం వాళ్ళు ఎవరో ఒకరిని బాగా ఫ్రంట్ కూర్చోబెట్టి దానికి రిప్లై ఇస్తున్నాను కూర్చోబెట్టి అంటే వేదికి మాట్లాడతలేదు సార్. డౌట్స్ కూడా ఏంటంటే వాళ్ళు ఏం చూస్తుంటే
Here the question comes whether we need to solve this, we need to take 360 model, we need to take a simpler model, or we need to take a simple cross section. Again, it depends upon type of analysis you want. Suppose if you want to do an analysis related to trade-off, then you need to take different. When you want to do analysis and you want to see results in the play, then this option cannot be because here we are simulating blade using simple muscle, not at all model blade. Here we are implementing gas source, pressure load, cycling and mass load, mass blade muscles.
కాదు రిజిస్టర్ కొత్త మారేదా బసవరాజు గారు అనేది
ఓఎస్డి సార్ ఏం లేదు ఓఎస్డి అయినేమో రిజిస్టర్ చేశారు చూస్తున్నాము ఓఎస్డి
డైరెక్టర్ ఆఫ్ ఎవల్యూషన్ కదా ఎవల్యూషన్ కదా డైరెక్టర్ ఆఫ్ ఎవల్యూషన్ కదా సాయిబాబు గారు
కాదు ఓఎస్డి అది కూడా ఓఎస్డి కూడా అందుకే సేమ్ పోస్ట్ మళ్ళీ ఎటు ఇటు
సాల్వ్ చేసుకుంటే ఇంట్రడక్షన్
media knowledge also about the so these are the different books which you can refer to final element knowledge. One important book here is Mechanical Engineering Information. Current element methods by Jntuk Moocs. Current element analysis by RT. You can refer access to market and these are the 5 books I have studied. Out of which for current element methods you can refer Jntuk Moocs and RT. These two are very good books.
శనివారం
శనివారం మార్చి